Welcome back to the Deep Dive. We're the show that really gets into the weeds on complex topics to pull out the practical knowledge you need.
Especially today, we're aiming this squarely at game developers.
That's right, we're tackling a really crucial part of the Lyra project.
Yeah.
Its ability system.
Yep, the ability system. If you're working with Lyra or even just, studying how it's built, this system is absolutely central. It's how you build skills, spells, manage stats, apply effects, all that core gameplay stuff.
Then understanding how it's put together, its basic layout,
Yeah.
it's essential if you want to use it effectively.
Absolutely.
So our goal today, our challenge really, is to figure out that fundamental structure just by looking at how things are named and organized within the system.
Yeah, we're basically trying to reverse engineer the design intent just from the names and the layout. No deep code dives yet, just reading the labels.
Like looking at the blueprints by reading the names on the rooms and corridors.
Exactly. And for you, the developer listening, getting this high-level map is key. It helps you figure out how to use it, how to extend it, maybe even modify Lyra's ability framework for your own game.
All right, let's get started. We'll begin at the top level, the foundational elements. These look like the core components, the big managers, everything else connects to.
Okay. So right away, if we're thinking about linking abilities to things in the game world, one name jumps out. LyraAbilitySystemComponent.
Right, component. In game dev, that usually means something you attach to an actor, right? Like a modular piece of functionality.
Precisely. You'd typically attach this component to an actor, could be your player character, an NPC, maybe even a weapon sometimes. It acts as that specific entity's hub for everything ability-related.
So my character in the game would have its own LyraAbilitySystem component attached, like its personal command center for skills and stats.
Exactly that. It's the character's dedicated processing unit. When the player hits a button to use an ability, the request probably lands here first for that character. And it likely manages their attributes, health, mana, stamina, and keeps track of any active effects on them, like speed boosts or damage over time.
Gotcha. So if you, as a developer, needed to, say, add a new grit stat to your character, or check if they can currently cast a spell because maybe they're silenced, you'd be interacting with this component on that character's actor.
That's almost certainly where you'd look first, yes. It's the entity's control panel.
Makes sense. Now, what about Lyra Ability Set? That also seems pretty fundamental. Set implies a collection.
Yeah, set strongly suggests a grouping, a bundle. So an ability set probably lets you package multiple abilities together.
Oh, okay. So instead of granting abilities one by one, you could create a set, like maybe a basic warrior set with attack, block, and shout.
Exactly.
Right.
Or the set of abilities granted by equipping a specific magic ring, or maybe a temporary set you get when you enter a special zone.
Right, like a prepackaged kit. So think of an ability set as a prepackaged collection ready to be granted.
Precisely. It's a really useful pattern for organizing and deploying groups of abilities cleanly. Define the set one, grant it multiple times.
Okay, and then there's the core building block itself, right?
Yeah.
Lyra gameplay ability. Even if the specifics live elsewhere, this name feels like the absolute foundation.
It really does. This sounds like the blueprint, the abstract class, maybe, for any single action or skill in the game.
Your jump, shoot, heal, dash. Each one is probably an instance of or derived from this Lyra gameplay ability.
That's the strong implication. This is likely where the fundamental logic resides. How an ability is activated, what it costs, its cooldown, what happens when it executes.
It's the individual verb in the character's action list. Understanding this base concept feels critical.
Definitely. It's the atom of action in the system.
Okay, moving slightly outwards now. We see things with global in the name. First up, LyraAbility System globals. What does globals usually suggest?
Globals typically points towards system-wide settings, configuration data, maybe shared helper functions that aren't tied to one specific entity.
So things that need to be accessible from anywhere within the ability system, like default cooldown values maybe, or system-wide rules, or shared utility code.
That's a very plausible interpretation, yes. It centralizes data or logic that should be consistent across the board, not specific to one character or one ability activation.
So here's a conceptual question for you listening. If the system needs a piece of information that's the same for all abilities or all characters using the system, where might you expect that information to be configured based on this file name?
The name Lyra System Globals strongly suggests it would be managed there.
Okay, but then there's also Lyra Global Ability System. That sounds similar, but
Okay.
What's the nuance? Global Ability System versus Ability System Globals.
It's a subtle but potentially important difference. While globals might be more about static data or config, global ability system often implies a runtime service or a manager, maybe a singleton, that oversees aspects impacting the entire system dynamically.
Ah, okay. So not just settings, but active management, like
Right.
what maybe handling network replication for ability effects across all players.
That's a great example. Or coordinating system-wide feedback, like those gameplay cues we might see later. Or managing interactions between different ability users that go beyond just one component.
So if globals is like the rule book, global ability system is more like the air traffic controller for abilities across the whole game.
That's a good analogy. If the Lyra Ability System component is the character's brain, the Lyra Global Ability System could be like the central nervous system coordinating everything at a higher level.
Okay, interesting distinction. Let's do a quick pause, a micro recap.
Yep.
We've looked at the foundational layer.
Yep, we've got the per entity hub, the Lyra Ability System component,
We have Lyra Ability set for bundling abilities.
the core ability blueprint, Lyra gameplay ability,
System-wide settings and LyraAbility System globals.
and a potential system-wide runtime manager, the Lyra Global Ability System.
Just these names alone sketch out a pretty robust component-based design.
They really do. It's just organization and scalability.
All right, let's continue peeling back the layers at this foundational level. We see LyraAbility tag relationship mapping. That's quite a name.
Yes, it's descriptive, though. Gameplay tags are huge in modern systems like this, used for categorizing everything. Tag relationship mapping tells us this is likely where the rules for how those tags interact are defined.
Interact, how so? Like defining that if you have the status.frozen tag, you can't use ability.type.movement tag.
Exactly like that. Or maybe that ability.damage. Fire tags deal double damage to actors with the state vulnerable.fire tag. It's the logic engine for tag interactions.
So it's not just labels. The tags have defined consequences managed here.
Precisely. It allows for complex, data-driven rules based purely on tags, which is super flexible. Here's a mnemonic to maybe help remember. TRM, tags relate and map.
TRM, tags relate and map. Got it. Okay. Next, Lyra gameplay ability target data single target hit. Wow, very specific.
Yeah, let's break it down. Gameplay ability target data suggests, well, data about the target of an ability.
Makes sense.
And single target hit narrows it right down. This sounds like a beta structure specifically designed to hold all the information about one successful hit on a single target.
So when my bullet hits an enemy, or my sword connects, this structure packages up the details, like who was hit, where they were hit, maybe the impact normal.
Exactly. All that crucial context about that specific hit event. This data would then be passed along, likely for damage calculation or applying other effects based on the hit location. It's the detailed report of that specific interaction.
So another conceptual question for the listener. When a projectile hits an enemy, where does the ability system likely store the specifics of that hit for applying damage?
Based purely on this name, an instance of Lyra gameplay ability target data single target hit is the prime suspect.
Makes sense. Moving on, Lyra Gameplay Queue Manager. We mentioned queues briefly with the global system. What does a dedicated manager imply?
Gameplay cues are usually the non-gameplay feedback, right? The visuals, the sounds, the camera shake.
Lushy stuff.
So a dedicated gameplay queue manager suggests a central system specifically for triggering and coordinating all that presentation layer stuff that's tied to abilities and effects.
Ah, so the core ability logic says I activated, or damage applied, and it notifies this manager.
Which then takes care of spawning the particle effect, playing the sound, maybe shaking the screen. It neatly separates the core mechanics from the cosmetic feedback.
That sounds like good design. Keeps the important logic clean. It's like the conductor of the visual and sound orchestra for abilities.
A perfect analogy. Okay, next up. Lyra gameplay effect context. We know gameplay effects modify attributes or apply states. What's a context for an effect?
Context, like the surrounding information. When an effect gets applied, it probably needs to know who caused it, right?
Yeah.
And who it's affecting, and maybe what ability triggered it.
Precisely. This gameplay effect context likely bundles all that crucial transient information for a specific instance of an effect being applied. The source, the target, the originating ability, maybe even that target data we just discussed.
And this is critical because the effect calculation often needs that context, right? A damage chef needs to know the attacker stats and the defender stats to figure out the final number.
Exactly. It provides all the necessary inputs. So let's pose another question. When a healing effect is applied, what structure likely carries the information about who casts the heal and who is being healed?
That sounds exactly like the job of the Lyra gameplay effect context.
Agreed. Okay, almost through this core layer. LyraAbility Source Interface. Interface is a key word here.
An interface defines a contract, right? A set of functions something must implement, but not the implementation itself. And ability source suggests this is for things that can originate an ability or effect.
That's the idea. This allows the ability system to interact with various potential sources, characters, weapons, items, maybe even the environment in a standardized way. As long as the object implements this interface, the system knows how to get source-related info from it.
So the system doesn't need special code for getting the source level from a character versus getting the source level from a magic item. It just calls a function defined in the interface.
Exactly. Its abstraction makes the system much more flexible and extensible. Think of it like a universal plug. Any potential ability source just needs to have the right socket defined by this interface.
Cool. That makes adding new kinds of gear or sources much cleaner.
Definitely. And the last one at this top level, Lyra Tag Actor.
Okay, tagged actor. This sounds like a base class for actors in the game world that's specifically designed to work well with gameplay tags.
That's the strong implication. Actors inheriting from Lyra Tag Actor would likely have built-in convenience functions for adding, removing, checking for tags, things the ability system relies on heavily.
So it's a helper-based class for developers. If you need an enemy character that needs to have tags like burning or stunned applied or checked frequently by abilities,
then inheriting from Lyra Tag Actor probably gives you a lot of that integration work for free. It streamlines making your actors tag-aware for the ability system. Conceptual question. If an enemy needs to have a burning tag applied by a fire ability, what base class might it inherit from to easily manage that tag?
based on this, Lyra Tag Actor seems like the intended choice.
Okay, wow. That was a lot just at the root level.
Yeah, let's do a quick mega recap of this whole foundational chapter before we move deeper.
We saw the core functions implied by these names: managing individual entities' abilities, LyraAbilitySystemComponent; grouping abilities, LyraAbilitySet; the basic ability definition, LyraGameplayAbility.
Plus, providing global services and config global ability system, defining system-wide tag interaction rules, LyraAbility tag relationship mapping.
Handling specific targeting data, LyraGameplayAbility target data single target hit; managing the visual and audio feedback, LyraGameplayQManager.
Carrying essential info for effects, LyraGameplay effect context. Providing a standard way to interact with ability origins, LyraAbility source interface, and a base actor class for tag integration, Lyra Tag Actor.
It paints a picture of a comprehensive, well-structured system right from the start.
All right, let's put those on flashcards for everyone listening.
Sure.
LyraAbility System Component, Entities Ability Hub, LyraAbility Set, Bundles of Abilities, Lyra Gameplay Ability Single Action Blueprint, LyraAbility System Globals, System-wide Config Helpers, Lyra Global Ability System, System-wide Runtime Service Manager, LyraAbility Tag Relationship Mapping, Tag Interaction Rules, remember TRM, Tags Related Map, Lyra Gameplay Ability Target Data Single Target Hit, data about a single hit target, Lyra Gameplay QManager, manages visual audio feedback, Lyra Gameplay Effect Context, info accompanying an effect application, LyraAbility Source Interface, standard way to interact with ability origins, Lyra Tagged Actor, actor base with tag support.
Okay, ready to move into the next layer.
Let's do it. Chapter 2. Diving into the specifics of abilities themselves. This area seems logically grouped around defining the actions characters can take.
And fittingly, we see Lyra Gameplayability conceptually central here again. It reinforces this is where the definitions live.
Right. And seeing names like Lyra Gameplayability Jump, Lyra Gameplayability Reset alongside it, well, that confirms a pretty obvious design pattern, doesn't it?
Absolutely. It screams inheritance. The base Lyra Gameplayability provides the common structure, and then these specific abilities, death, jump, reset, inherit from it and add their unique logic.
They're like concrete castings from the general Lyra Gameplayability mold.
Exactly. So, listener, question. Given that other abilities reside here, what principle of object-oriented design does this structure strongly suggest Lyra's abilities utilize?
The clear answer is inheritance. If you want to make a new ability, say dash, you'd inherit from Lyra Gameplayability.
All right. Promotes reuse, consistency. Now, also in this section, we see things related to liability costs.
Okay, straightforward enough. Abilities aren't always free. This suggests a system for defining and handling the resources they consume.
Yep. And just like with abilities, we see a base concept, LyraAbility cost, and then specific types of costs.
Yeah, I see LyraAbility cost inventory item, LyraAbility cost item tag stack, and LyraAbility cost player tag stack. What do these tell us?
They tell us the system is flexible. Inventory item is pretty clear. Using this cost type means the ability consumes an item from the character's inventory.
Okay, makes sense, like using a potion. What about item tag stack? Consuming a tag on an item.
Yeah, think about charges on a magic wand or ammo and a specific clip item. The cost depletes a resource tracked via a tag on that item.
Ah, cool. And player tag stack.
That suggests consuming a resource tracked directly on the player via tags, but not tied to a specific inventory item. Think stamina points or maybe a generic mana pool represented by tags.
So it gives you multiple built-in ways to handle resource costs before you even need to think about writing custom logic. That's pretty powerful. Another question for you. If you wanted to add an ability that costs ammunition from a specific weapon, based on these names, which cost type seems most relevant, or would you expect to create a new one?
A LyraAbility cost item tag stack seems like a strong candidate if ammo is tracked on the weapon item itself, or perhaps player tag stack if ammo is a general pool on the player. You might not need a new one immediately.
Good point.
Yeah.
Okay, one more in this ability section. LyraAbility Simple Failure Message.
This name suggests a standardized way for the ability system to tell you why it couldn't activate an ability.
Right, because failure happens, not enough mana, it's on cooldown, player is stunned, whatever. This sounds like it provides structures or codes for those common failure reasons.
Exactly. Crucial for giving feedback to the player. Can't do that, not enough mana.
Yeah.
And also really important for debugging. It's the ability system's way of saying, nope, can't do that because...
Like a standardized error reporting system for abilities.
Very much.
Okay, let's do a micro recap for this ability section. We saw the clear use of inheritance for defining specific abilities based on Lyra gameplay ability.
We saw the flexible system for handling different types of ability costs, inventory items, item tags, player tags.
And the mechanism for standardizing failure messages.
This whole area really details the verbs of the system, the actions, their costs, and their basic activation rules.
Let's hit the flashcards for Chapter 2. Lyra gameplay ability, base ability, Lyra gameplay ability death jump reset. Specific ability examples using inheritance. Lyra ability cost, base for ability cost. Lyra ability cost inventory item. Cost by consuming items. Lyra ability cost item tag stack. Cost by item tags, these charges. Lyra ability cost player tag stack. Cost by player tags, you have use stamina. Lyra ability simple failure message. Standard messages for ability failures. All right, Chapter 3. Attributes. This grouping seems clearly focused on the stats, the numerical properties of characters and other entities.
Yep, your health, mana, strength, agility, all those core numbers that define an entity's state. This section is about how Lyra organizes that data.
And the key concept seems to be Lyra attribute set. What does this imply?
Well, again, set suggests the collection. It strongly implies that attributes aren't just loose variables, but are grouped together logically within these sets. An attribute set is likely a container holding related stats, probably owned by the LyraAbility System component.
Okay, so you wouldn't just have a health variable floating around. It would be part of a set. Question for the listener. If a character has health, stamina, and mana, would you expect each to be in its own Lyra attribute set, or grouped together? What does the structure suggest?
The structure strongly suggests they'd be grouped, likely within one or more attribute sets attached to the character. The base Lyra attribute set probably provides the framework for defining, replicating, and modifying these groups of stats.
And we see specific examples here too. Lyra health set and Lyra combat set.
Right. Lyra Health Set is pretty self-explanatory. This is an attribute set specifically for holding health and survival-related attributes. You'd expect to find things like current health, max health, maybe health regeneration, armor values inside this set.
It's like the vital statistics page on a character sheet.
Exactly. And Lyra Combat Set would then logically group the stats relevant to fighting.
Like attack power, defense, crit chance, maybe attack speed.
Precisely those kinds of things. Anything directly related to combat effectiveness would likely live in the Lyra Combat Set.
So, thinking about Lyra Health Set and Lyra Combat Set together, how does organizing stats this way help manage a character's potentially complex statistics?
It provides clear separation and modularity. If you're working on healing mechanics, you know to look at the health set. If you're balancing weapon damage, you focus on the combat set. It keeps things organized, easier to manage, and probably helps with network replication too, sending related chunks of data together.
Okay, quick recap of attributes. The core idea is organizing stats into logical groups called attribute sets,
with specific examples provided like Lyra Health Set for survival stats and Lyra Combat Set for combat-related stats.
This structure promotes clarity and modularity in handling character data.
Flashcard time for Chapter 3. Lyra Attribute Set. Base for attribute collections. Lyra Health Set. Health survival attributes. Lyra Combat Set. Combat-related attributes.
Moving right along. Chapter 4, executions. Now, execution sounds like actually doing something, applying the effects we've talked about.
That's the strong implication, yes. If a gameplay effect says what should happen, like deal 10 fire damage, the execution likely contains the specific logic for how that change is actually calculated and applied to the target's attributes.
Ah, so the effect is the intent, the execution is the calculation engine. It takes the effect's base value, maybe the context we discussed,
Like the source's stats from their combat set, the target's stats from their health set and combat set, like resistances or armor.
and crunches the numbers to figure out the final health change.
Exactly. It separates the definition of an effect, deal fire damage, from the complex calculation logic needed to apply it in the game world. This is a really important separation of concerns.
And we see specific examples, Lyra damage execution and Lyra heal execution.
Lyra damage execution seems clearly dedicated to handling the calculation and application of damage. It takes all the inputs, effect, magnitude, source stats, target stats, maybe critical hit chances from the combat set, and determines the final damage number that gets applied to the target's health attribute, which lives in their health set.
It's the damage formula black box.
Pretty much. And Lyra heal execution is the counterpart for healing effects. It contains the logic to determine how much health is actually restored.
So, posing this question again slightly differently. When a healing ability is activated and a healing gameplay effect is applied, which element listed here is most likely responsible for determining how much health is actually restored based on stats and context?
Lyra heal execution is the named component that fits that role perfectly.
Okay, so the execution section is about the specific logic engines that apply attribute changes based on gameplay effects like damage and healing.
Correct. It's where the effect's intent meets the game's mathematical reality.
Micro recap complete. Flashcards for Chapter 4. Lyra damage execution. Logic for applying damage effects. Lyra heal execution. Logic for applying healing effects.
Makes sense. Ready for the final chapter based on the structure?
Let's do it. Chapter 5. Phases. This is unexpected, maybe? Finding game phases within an ability system structure.
It is interesting, isn't it? It suggests the scope of Lyra's ability system might be broader than just character actions. Phases clearly points to managing distinct stages of gameplay like setup, play, round over, scoreboard, etc.
And we see Lyra game phase subsystem. Subsystem usually means a global manager, not tied to one actor. So this sounds like the main controller for the game's overall flow.
That seems highly likely. The Lyra game phase subsystem is probably responsible for tracking what phase the game is currently in, handling transitions between phases, and maybe activating phase-specific logic. It's the game's high-level state machine manager.
Okay, but here's the really intriguing part. Lyra game phase ability. This name implies that moving from one game phase to another might actually be implemented as an ability, like a Lyra game play ability.
That is a fascinating design choice, if true. It suggests they might be leveraging the entire ability system framework activation, prediction, maybe even costs or cooldowns, replication to handle high-level game state transitions.
Wow. So instead of building a completely separate system for managing game flow, they potentially plugged it right into the ability system. How does structuring game phase transitions as Lyra game phase ability instances potentially simplify or unify the design compared to a separate ad hoc state machine?
Well, it unifies the core logic patterns. You use the same system, the same concepts, for character actions and for major game state changes. You get replication, prediction, maybe even tag checks for conditions, all potentially handled by the existing ability system infrastructure. It avoids having two separate complex state management systems.
That could be quite elegant, actually. Less code, more reuse.
Potentially, yes. And finally, in this section, there's Lyra game phase log.
A dedicated log just for phases. That suggests they built in observability. Tracking phase transitions must be important for debugging, especially in multiplayer.
Absolutely. Having dedicated logging points to a system designed with diagnostics in mind makes it easier to understand how the game is flowing from one state to the next.
Okay, so the phases section suggests Lyra might use its ability system not just for characters, but to manage the entire game's lifecycle.
With a dedicated subsystem, transitions possibly modeled as abilities, and built-in logging.
Mega recap for phases. It seems to handle overall game state through distinct phases, potentially using the ability system itself for transitions, and includes logging.
Final set of flashcards for Chapter 5. Lyra game phase subsystem manages overall game phases. Lyra game phase ability potentially representing a phase transition. Lyra game phase log, logging for phase system.
Wow. That brings us through the entire structure. Just based on the names and organization, we've journeyed from the core components right up to potentially managing game phases.
It's amazing how much you can deduce just from careful naming and logical grouping. We saw the per entity hub, ability sets, the base ability concept.
The global managers, the tag rules, specific data structures for targeting and context.
Then deeper dives into ability definitions with inheritance and costs, attribute organization into sets.
The execution logic for damage and healing, and finally, the game phase management potentially integrated into the ability system itself.
The whole thing paints a picture of a well-thought-out, component-based modular system that leverages common patterns like inheritance and separation of concerns.
And for you, game developer listening, understanding this layout, this map, is really your first crucial step. It helps you know where to look, where different kinds of logic likely reside, so you can start using, extending, and building on Lyra's ability system more confidently.
You now have the blueprint based on the labels. You know the conceptual rooms and floors of this system.
Exactly. So we've seen the what and the where just from the names. Here's a final thought to mull over as you perhaps dive deeper into the actual code later.
We've seen the static structure, but what intricate connections, what dynamic interactions between these components actually bring the system to life? How does that gameplay effect context actually flow from the ability activation through the gameplay queue manager into the damage execution to modify an attribute in the health set?
That's the next layer, understanding the runtime dance between all these parts we've identified. The structure is the stage, but the implementation is the performance. Think about how those pieces dynamically interact.